Greetings traveler to the third expedition of the Mithra Program, to which we were previously exploring the world of Eden. Lately we sent the V to Mithra probe to orbit around the world of Eden, where we have received information that the planet of Eden hosts life, both uni and multicellular, with the two main kingdoms being the animals and the plants that call this wonderful world their home. We have now been green-lighted to conduct a newer, more advanced mission, which would take us deeper into the oceans of this planet. As we travel through space, we pass from the edges of the Mithra system and slowly get ever closer towards Eden. Upon our impending arrival, we take a quick flyby near the largest planet in the system, Irati, the colossal green gas giant that roams around the fourth orbit around the star. As we pass Irati, we admire its rings, which from the data collected from the probe seem to be made up of ice particles and hydrocarbons, which make up its light tan to brownish colors. We continue to admire and examine the magnificent array of particles until suddenly a large clash knocks us off orbit. Our small probe was knocked into disarray as the clash damaged it beyond repair. The thrusters activate on the probe and we begin to stabilize ourselves. As we slowly come to a rotational stop, we see that the object that has hit us was a rogue comet. Thankfully, the comet has only grazed us by the side. Soon enough, we are on our journey again, but this time missing a few parts. Soon enough, we finally enter the quarters of Eden. We orbit high above it, where the entire planet is in view, alongside its magnificent moon. We began our burn-off and began to slow down our craft. After some time, we make a stable, low Eden orbit, where we will scan the surface of the planet, taking in a projection of the surface as a map. After a few orbits, we finally take a full projection of the planet and unveil a map of the world. Most of the planet consists of barren desert wastelands, but our key interest is the equatorial ocean that spans across the planet. From space, we cannot see or observe anything living deep within it, which is why we brought alongside ourselves a lander. As we reach our desired place in orbit, we detach the probe. The probe now descends and begins to enter the atmosphere. The probe lets out a loud roar as it pierces through the atmosphere until finally it splashes down onto the ocean. Finally, we enter our new stage of the mission, exploration. Our quote-unquote lander was but a submersible, which would allow us to explore the planet with an in-depth analysis of both the abiotic and biotic factors of the world. As we begin to descend into the depth of this mighty ocean, we finally reach the sea floor. Upon arrival, we see nothing but the sea floor. Let's keep exploring. Aha, we at last found something. We begin to get closer, and in a deeper analysis, we discover a new form of life. This biofilm is its own complex ecosystem consisting of a layered community of microbial life, such as bacteria, protists, and cyanobacteria, that call this region their home. The layer of the mat we are most interested in is the topmost layer, which contain photosynthetic microbes that harness the sunlight to make food, while the layers that reach deeper within the microbial mat are primarily composed of bacteria. As we pass above the microbial map, we catch something extraordinary. Feasting on top of the mat is what seems to be a radial symmetrical creature that slowly moves on top of the biofilm, creating a sort of mucus on its footpads, which help it glide across the surface of the mat. Its radial body plan suggests that it only has one opening at the bottom of its body, which is used for all bodily functions, such as eating, digesting, defecation, and reproduction, similar to that of a Tellus anemone or starfish. These radial life forms reproduce sexually, where the male would climb above a sack of eggs in the sand and release its gametes to fertilize the eggs, and after a fortnight, the eggs would hatch, and the new generation of the radial species would hatch. They're around the size of a Romani coin, which means that they could easily fit in your hand. These creatures will be known as the parapede. The parapede's role in this world is to keep the microbial mats in check. Without them, then the entire sea floor would be covered in these layered colonies. We depart from the microbial mat and begin our journey henceforth. As we explore, we spot something far off in the distance. Our probe is signaled to move towards movement, as visible movement means that there is life aboard. As we get closer, we spot a family of worm-like creatures swimming along the ocean currents. Upon a closer look, we finally see its full image. These worm-like creatures are mobile swimmers, which use the ocean currents to move them from place to place, while swimming in a sort of anguilliform locomotion, where they use their entire body for propulsion. These creatures are the first to exhibit eyes in our journey, and although they're still just primitive organs for sight, they have a full 360-degree angle of their environment due to the way their 5 eyes are structured around the top of their heads. These creatures are around an inch in length and come in brown to tan-like colorations. They don't have a true skeletal structure consisting of calcium bones, but instead have a hydrostatic skeleton, which is a support system that uses fluid pressure to maintain the animal's shape and allows it to move. These creatures are microvivores, which means that their diet consists of free-floating microorganisms that also use the ocean currents to move around. We will call these creatures Tinius. The Tinius have an advantage to all other life forms we've discovered, as they have a bilateral body plan, which favors locomotion, as it allows the creatures to exhibit a more streamlined body, thus possibly giving rise to far more complex creatures. As we take in the information and send it to our orbiter, the family of Tinius swim away and slowly disappear within the ocean background. We redivert our probe and begin ascending towards the surface of the water. As our tiny probe propels itself up, we detect floating masses of objects above us. We slow down and come to a stop at the water's edge, where we enter a school of swimming ball-like organisms. At first, our probe detects them as inanimate objects, but as we take a closer look, they are indeed alive. These floating creatures seem to be similar to that of Tellus jellyfish, but with these creatures being a bulb with a tail they drag behind. In a closer inspection of these, it seems that their skeletal structure seems to be that of a hydrostatic skeleton, which is similar to that of the paripede we've encountered earlier, suggesting an evolutionary link between them. If you've forgotten, a hydrostatic skeleton is a support system that uses fluid pressure within a closed cavity to maintain the shape, provide support, and assist with movement for an animal. These creatures are simplest life forms we've encountered so far in our journey, with them lacking a skeletal structure and organs. They have no true organs, but what they do have are simple eye spots, which only purpose is to detect the changes in light in its environment. What intrigues us the most of the sort of tail that these organisms seem to drag behind. But before we could speculate what they could be used for, we get a demonstration of what they are. Not far from where we are, we spot motion coming from these still organisms, and as we zoom in, we see that the tail they are dragging behind is a sort of tentacle that they use to catch and grasp onto free-floating zooplankton, to which they would reel in and digest inside of their bulbous head. We will call them bulbidants. We begin to slow down and watch as the bulbidants slowly drift away until we finally begin to descend once more onto the surface of the ocean. Our probe slowly descends near the bottom of the sea, and we begin to see some familiar faces. Fortunately, the Rotunmis have survived well into the Cardian Explosion. Our probe gets a closer look and spots a Rotunmis desolated from the rest. We watch as it strays away into uncharted territory, but that was a mistake. From the sand, a huge predator in comparison appears, chomping down on the Rotunmis before dragging it into the sand. From this attack, we spot yellow blood spewing from the sand and left behind from the attack. As of now, we know the color and could speculate on its proteins, but our probe wasn't built for direct contact, so as for now, we can just observe. We play back the footage and analyze the predator that succeeded in the hunt. This carnivore is amongst the first and is the foundation of a lineage that might be the ruling dynasty of the planet. The creature we see is slender, yet armored with a sort of plating consisting of calcium carbonate which surrounds its soft body, hinting at the first shelled creatures to exist. These creatures are the largest we've ever seen and the most dangerous we've encountered on our journey. They have the first primitive mandibles that are supported by a hydrostatic skeleton, the same as all the other creatures on this magnificent world. We shall name these creatures the Speculative. Unfortunately, our journey to this planet is short and comes to a sudden end, as our battery is slowly drained. We use the last bits of our energy and locate a cave, where we will stay hidden from the rest of the planet and rest for eternity. Good night. Connecting back to our probe, we receive the observations recorded by our submersible and shoot the transmissions back home. In today's mission, we've explored the beginnings of the Cardian Explosion, where life is beginning to take root on the planet and thrive. The species discovered today are the foundations of future dynasties that will rule the planet. But before we know, we must come to a stop. This marks the third expedition to Eden, where we've uncovered the first spark of life slowly growing across its ocean. Visit our journey on the next mission, where we will arrive onto the planet in the following 30 million years.